In this lesson, we're going to talk about patterns, equations, and graphs. So far, we've talked about equations with one variable. Today, we're going to start talking about equations with two variables. A solution of an equation with two variables, x and y, is an ordered pair. An ordered pair is written in parentheses. The x value comes first, separated by a comma, and then the y value. That makes the equation true. So you're looking for an x and a y that when you plug it in, you end up with a true statement or an identity. The first example says, is 515 a solution of the equation y equals 3x? This is a pretty basic two-variable equation, y equals 3x. The ordered pair that they give us is 515, meaning 5 is the x value and 15 is the y value. You need to go ahead and substitute in both 5 for x and 15 for y. When you plug that in, instead of y equals 3 times x, you're going to have 15 equals 3 times 5. Super basic, 3 times 5 is 15, so you end up with 15 equals 15, which means the ordered pair 515 is a solution to the equation. If you would have ended up with a false statement, something like 15 equals 2, for example, it would not be a solution to the equation. The next example asks us to determine if 2, negative 2 is a solution to the equation y equals 5x minus 8. The ordered pair 2, negative 2 tells us that 2 is the x value and negative 2 is the y value. That means we need to substitute 2 in for x and negative 2 in for y. Go ahead and plug them in, which means you would have negative 2 equals 5 times 2 minus 8. Well, 5 times 2 is 10, and then 10 minus 8 is a positive 2. Negative 2 does not equal positive 2, so 2 negative 2 is not a solution to the equation. There are different ways to show a relationship between two variables. You can create a table to show the corresponding x and y values. You can write an equation, and you can also draw a graph. If you're drawing a graph, you do need to make sure that you label your axes. The next example says Will runs 6 laps before Megan joins him. Then they run together at the same pace. Represent the relationship between the number of laps Will runs to the number of laps Megan runs using a table, an equation, and a graph. Using a table, we can have, I set up my table to go horizontal. You could have a vertical table as well. I set up Megan's laps are in my top row and Will's laps are on the bottom row. Again, they could be switched. It just depends on your preference. When Megan runs 0 laps, I'm just going to go ahead and plug in 0, 1, 2, 3, and 4. If you read what it says, when Megan's run 0 laps, Will has run 6 because it says he runs 6 laps before Megan joins him. But then they start to run together. So once Megan's run 1 lap, that's actually Will's 7th lap. When she runs 2 laps, that would be Will's 8th lap. 3 laps for Megan would be 9 laps for Will. And finally, Megan's 4th lap would be Will's 10th lap because he's run 6 more laps than she has. We could express this relationship in an equation where we're going to let x be the number of laps Megan has run and y be the number of laps Will has run. It is important that you go ahead and define your variables. You could also choose to use an M for Megan and a W for Will. That would be an option. When we start to graph things, though, which is the third thing that they ask us to do, it is more common and, well, just typically you're going to use X and Y. So if y is Will's laps, x is Megan's laps, we could use the equation y equals x plus 6. And then the last thing that they asked us to do was to make a graph. So on the next slide, I'm going to copy my table. And then I'm going to create a graph from that table. In this case, I am using axes, but I've labeled it Megan's laps and Will's laps. And I'm just going to plot the points. So when Megan has run 0 laps, Will has run 6. When Megan has run 1 lap, Will has run 7. 2 laps, Will has run 8. Megan's third lap is Will's 9th. And then her 4th lap would be Will's 10th. Notice I did go ahead and give my graph a title as well, Megan's and Will's laps. So I've labeled my axes, and I have a title for my graph. The last example says the table shows the relationship between the number of chairs and the total number of legs. Extend the pattern. What is the total number of legs on 10 chairs? The pattern shown in the table is, if you look at the x and the y, you're trying to find something that you can do to the x value, to each x value, to get its corresponding y value. Meaning, what can you do to 1 to get 4? And what can you do the same to 1 to get 4 when you start with 2 to get 8, and then when you have 3 to get 12, when you have 4 to get 16, and when you have 5 to get 20. This is a pretty basic pattern, right? You can multiply all of the x values by 4. So multiply the number of chairs, which is your x variable, by 4 to find y, the number of legs, which means if we have 10 chairs, we would multiply 10 times 4, and we would have 40 legs. That's some pretty basic two-variable equations, setting up equations, deciding if an ordered pair is a solution, how to write a table and make a table and a graph and an equation. Pretty basic stuff today. As we get further into functions and relationships and linear relationships, it will definitely become a little bit more complicated.